It's 7:45 in the morning, and Sarah sits down with a coffee and opens the spreadsheet she spent 5 years trying to control. She hasn't even taken a sip, and three things have already changed in her warehouse overnight without her touching a single button. A demand forecast rebuilt itself at 3 in the morning. A reorder threshold moved on its own. And a careful little email to a supplier who'd gone quiet got drafted while she was asleep. Sarah used to spend about 90% of her week chasing updates and maybe 10% actually deciding anything. Something just flipped that ratio. And none of what changed overnight was magic. It was a handful of narrow tools, each doing one unglamorous little job. A forecast here, a reorder point there, the first draft of an awkward email, not a robot uprising, just a quiet rewiring of who does what. So over the next 40-odd minutes, I want to answer 4 questions. What is the machine Sarah sits inside? And why does it break? What does AI actually do about it? When people went and studied this properly, what did they actually find? And where do the smart, serious people still disagree? Stick with me to the end, and you'll be able to hold your own on all of it. The ideas and the real cases behind them. First, the machine. Before you can fix a supply chain, you have to see it for what it really is. A machine with 5 moving parts. You plan what people are going to want. You source the materials. You make the thing. You deliver it. And when something comes back, a return, a repair, a recall, you handle that too. Plan, source, make, deliver, return. 5 links. Hold on to them because everything else hangs off this. Now, here's the genuinely maddening thing about that chain. And once you see it, you can't unsee it. Picture a supermarket. On Tuesday, customers buy 10 more boxes of cereal than usual. Nothing dramatic. But the store manager thinks, ooh, better order 15 just in case this is a trend. The distributor upstream sees that 15-box order and thinks, right, demand's picking up. Let's make it 25 and grab the bulk shipping rate while we're at it. And by the time that little ripple reaches the factory, they're gearing up to make 50. A 10-box wobble on a quiet Tuesday becomes a 50-unit swing at the factory. And here's the part that gets me. Nobody panicked. Nobody was being silly. Every single link did the perfectly sensible thing, and the system still cracked the whip. So, what does AI actually change here? Not the arithmetic, the eyesight. Instead of every link nervously guessing from the padded order in front of it, a machine learning forecast can hand all of them the same true signal, the real demand, straight from the shelf. And when everyone's reading the actual number instead of each other's guesses, the whip loses most of its crack. 2 quick asides before we move on. First, none of this is new. That amplifying wobble was described by a man called J. Forrester back in 1961, decades before anyone was saying the word AI. So when someone sells you AI as the cure, just quietly remember, it's the newest tool pointed at a very old problem. And that textbook fix? Just give everyone visibility. It sounds gloriously simple, doesn't it? Put the shelf data in the cloud, wire the factory up to the checkout scanner, job done. It fits beautifully on a slide. In real life, that data belongs to rival companies who, frankly, dislike each other. It's sitting in ancient computer systems, held together with duct tape and hope. And sharing it is usually nobody's actual job. One last idea to carry the whole way through. Every call Sara makes is a tug of war between 3 things: cost, speed, and resilience. How cheap, how fast, and how well it survives a shock. And the catch is, you can't max out all 3 at once. Cheaper and faster usually means more fragile. Sturdier usually costs more. And a lot of what AI quietly promises, Underneath all the jargon is just this: bend that triangle a little. Buy yourself some resilience without paying full price in the other two. Whether it actually delivers is something we'll keep poking at. So, whether you're sitting an exam on this or just trying to keep a real warehouse running on a Monday morning, keep 3 things in your pocket: the 5 links of the chain, why a small wobble turns into a big swing, and why you can't have cheap, fast, and unbreakable all at the same time. That's the machine. Next, what happens when we start letting it make the decisions? So, the machine breaks in predictable ways. What does AI actually do about it? And I promise you, under the hood, it's a lot less science fiction than the brochures suggest. Here's the whole toolbox: 6 narrow jobs: forecasting demand, optimizing inventory, safety stock and reorder points that move themselves, predictive maintenance, spotting a machine that's about to fail before it fails, optimizing routes and networks, automated negotiation and visibility, one live view over the whole chain. None of them is a genius. Each one just does a single job. Well, put them together and they quietly rewire how the whole thing runs. You'll see names attached to these: O9, Symbotic, C3 AI, Blue Yonder, Kinaxis, Coupa, Amazon's industrial machine learning. Don't bother memorizing the logos. Just notice the shape of the market: something for planning, something for inventory, something for the warehouse robots, something to orchestrate it all in one screen sitting over the top. IBM has a tidy name for that stack: the trifecta: data plus AI plus cloud. You bolt a cloud and AI layer on top of the creaky systems you already own, and suddenly you can run the whole chain from a single pane of glass. They're one piece of advice, and it's good advice. Start small, but start. And here's what IBM says you get for it: 7 benefits: lower costs, real-time decisions, fewer errors, and less waste; smarter inventory, a better run warehouse, more sustainability, and the ability to simulate before you commit. Hold on to that list, because in a couple of chapters, we're going to audit every single line of it. Quick look under the bonnet. How does a model actually get built? 3 stages: data, discovery, development. You gather and clean the data. You explore it and find a model that works. Then you develop it into something that runs in production. And that little loop sits wrapped around the whole operational cycle: sense, plan, source, make, deliver, sell, service, engage. Now here's the least glamorous, most important part of the whole module. Before any of that clever stuff works, someone has to deal with the paperwork: invoices, bills of lading, customs forms, packing lists, mountains of messy, unstructured documents. There's a branch of AI called natural language processing, NLP, that reads all of that, cleans it up, and turns it into data the models can actually use. It is deeply boring plumbing. It's also the thing that makes every shiny dashboard possible. On honest clarification, almost everything I've just described is machine learning: supervised models and optimization quietly running in the background for years. Powerful, but not new and not magic. The genuinely new bit, the chatty, generative AI, the co-pilots and the drafting, is newer, narrower, and it can confidently make things up. Brilliant assistant, unreliable oracle. So, to carry out of here, name a few of those jobs: forecasting, inventory, maintenance, routing, negotiation, visibility. Know what NLP does? It turns messy documents into clean, shared data. And be able to tell ordinary machine learning forecasting apart from a generative AI copilot. That's the toolbox. Next, onto the factory floor and the one study that actually went and looked. Everything so far has been what AI could do. Now, let's go and see where it actually landed, because somebody did the unglamorous work of counting. First, a map. Any supply chain breaks down into 6 standard processes. It's called the Daisigauer model. 5 you run in sequence: plan, source, make, deliver, return. And one that wraps around all of them: enable. That's your data, your business rules, your risk, your compliance. It's the unshowy 6th process. And it's exactly where AI governance lives. Forget it in an exam and you'll drop marks. So don't forget enable. Now the study. Canas and 3 colleagues didn't run a survey, they went inside. 6 Italian manufacturers, firms A through F, and 17 real AI projects, each one mapped onto a S-score process. So instead of guessing where AI shows up, they could actually count. And here's the pattern nobody puts on a conference slide. Of the 17 cases, 13 landed in make, the factory floor. Not the clever strategic planning layer everyone loves to talk about, the actual physical making of things. Why the floor? Because of a number of factories live and die by called OEE, overall equipment effectiveness. It's availability times performance times quality rolled into one figure. It's measurable, it's yours, and it moves fast. And that's precisely why AI lands there first. It's where you can prove it worked. Here's what those 17 projects actually delivered. Count it up. Cost savings, 15 times. Shorter lead times, 9. Better OEE, 6. Then service, quality, safety, a few each. And sustainability, once. Cost and speed dominate. Sustainability barely registers. Hold that thought, because it's about to collide with the vendor slides. And this is the bit worth really understanding. Why the floor and not the plan? Because make runs on your own machine sensor data. Clean, owned, quick to prove. Plan needs rival firms to share their data with you, plus a big upfront bet before anyone sees a return. That's the hardest wall in the whole chain. The barrier isn't the technology, it's data you don't own and trust you don't yet have. The paper does look ahead to an idea it calls digital cognitive manufacturing. Cognitive computing plus the Internet of Things plus AI fused into factories that sense, decide, and improve on their own. It's the successor to today's one-off point solutions. Mostly still a promise, but that's the direction of travel. Credit where it's due. Here's the source in full. Canas, Ciano, Saltalamacchia, and Secchi, 2024 in the International Journal of Production Research. Careful, real work, and keep this in your back pocket, still just 6 Italian firms. Because here's the other side. 13 of 17 in make might not mean make matters most. It might just mean make is where results are easy to measure. A kind of spotlight effect where you find AI wherever the light is brightest. And 6 firms who agreed to be studied are not a random slice of the world. It's great evidence for Italian manufacturing. It's a much weaker guide to your industry. So, name all 6 S-core processes, enable included. Say why AI concentrated in make, not plan. And define OEE and DCM and know that cost was the most cited benefit. That's the evidence. Next, those vendor numbers, under a much brighter light. Every deck about AI and supply chains has the same slide, a wall of enormous confident percentages. Let's put that slide under a brighter light. Here are the 6 headline numbers you're meant to believe. 65% fewer lost sales. Over 80% of logistics firms on AI by 2030. 15% lower costs. 20 to 50% fewer forecasting errors. $1.3 trillion added to the world economy by 2026. $41 billion saved a year by 2030. Impressive. And every single one of them traces back to one 2024 vendor blog. And that's the distinction that'll serve you for life. On one side, company reported numbers and projections, a vendor's forecast of the future, useful signposts, not evidence. On the other, independent, peer-reviewed findings, like the reading's cost and lead time counts, smaller, duller, and far, far sturdier. That's what evidence actually looks like. So keep 3 questions in your pocket for any AI statistic. Who measured it? A vendor selling the tool or an independent study? On how many cases? 1 hopeful pilot or 17 real ones? And compared to what? Better than nothing or better than the old way? And notice, 2 of those 6 numbers are projections for 2026, which means by the time you're watching this, they're already testable against reality. So, recall a couple of those headline numbers and the one vendor blog caveat. Name 1 well-evidenced benefit, cost, and 1 weak one, sustainability. And run the 3 questions, sabasto. Numbers, handled. Next. If it's this good, why isn't it everywhere yet? If AI in operations is so real and the payoff so clear, why hasn't Sara's company rolled it out everywhere? Because between here and there is a series of walls. Here are the walls she keeps hitting. Training cost. New tools mean downtime and retraining. Startup and running costs. Pilots that never scale. Complexity, sensors, and models strung across a global chain. And the AI-specific risks. Bad data in, overtrust out, and a nagging worry about security and privacy. Underneath all of it, data trapped in silos, in aging systems that won't talk to each other. And people, trust, and a very human resistance to change. So how do you get through? The consultancy Deloitte lays out 5 steps, and they're worth knowing in order. 1, strategy and roadmap. Get this wrong, and the rest collapses. 2, change management. Win people's trust and track the value out loud. 3, the tech stack, a flexible architecture underneath. 4, data preparation, clean, label, contextualize. That, by the way, is exactly where our boring hero NLP earns its keep. And 5, use case activation, business-led, self-funded, and built with the people who will actually use it. And notice how this rhymes with the reading. AI landed in make because it runs on your own clean sensor data. Plan stayed empty because it needs rivals to share theirs, and a big bet before any payoff. So the real barrier, again, isn't the technology. It's data you don't own and trust you haven't built yet. IBM's advice, remember, was start small, but start. And here's the honest flip side. Not every process should be automated. Sometimes a human in the loop isn't a barrier to be engineered away. It's the feature that keeps you safe when the model is confidently wrong. So, name 3 real challenges to adoption, list Deloitte's 5 steps, and explain why Canis found the AI on the floor, not in the plan. That's the how. Next, a real company told properly, Walmart. Now, a confession. In the short version of this, we made Walmart sound like a flawless AI success story. It isn't. And the honest version is genuinely more useful. Start with a good bit, and it is good. Walmart Canada ran a pilot with an AI negotiation bot from a company called Pactum, and they pointed it at exactly the suppliers a human team never has time for, the thousands of tiny tail-end vendors. Walmart reported that about 2/3, 68% of the suppliers it approached reached a deal. But say that word out loud, reported. That figure comes from Walmart via a Harvard Business Review piece. It hasn't been independently audited. Keep that in mind. Because here's the part that doesn't make it onto the slides. For years, Walmart rolled out shelf-scanning robots from a firm called Bossa Nova. And in November 2020, they scrapped the whole contract. It turned out humans did about the same job, for less. AI in retail operations is not a straight line of wins. The honest story has dead ends in it. So, what is the real Walmart story? It's something with a boring name, Element, their in-house machine learning platform. It cut the time to get a model into production from weeks down to under an hour. No headline, no robot, just the plumbing that makes everything else possible. And honestly, the part actually worth copying. Now, the case study asks 5 questions, and I want to walk them because these are exactly the kind of thing you'll be asked to discuss. 1, could a tool like Pactum work for small businesses? In principle, yes, because the cloud makes it cheap. But small firms lack the supplier volume and the data, so realistically, it'd come through shared platforms, not going it alone. 2, the ethics of dynamic pricing in an emergency? Efficient, yes, but it risks straying into price gouging, so it needs guardrails, caps, and transparency about when and why prices move. 3, how do you keep these AI decisions transparent for the suppliers and customers on the receiving end? Explainable models, a genuine route to appeal, and simply disclosing that an AI is doing the negotiating or the pricing. 4, what about the workers displaced by all this automation? You move them from chasing to judgment, exception handling, supplier relationships, oversight, and you back it with real retraining, not a slogan on a poster. And 5, the big one, can AI build resilience against pandemics and geopolitical shocks? It can sense disruption earlier and replan faster, but it cannot conjure up buffers, backup suppliers, and slack out of nothing. Hold that thought. It's the whole of Chapter 9. One more because honesty demands it. When a bot negotiates with your smallest suppliers, suppliers who don't have bots of their own, who holds the power? Automated negotiation is efficient. It can also quietly tilt an already tilted table further towards the giant. Efficient and fair are not the same word. So, say what Pactum did, and the caveat, 68% is company reported, not audited. Walk those 5 questions. That is your discussion prep. And remember the honest arc. A scrapped robot, a quiet platform, a real win. One company, seen clearly. Next, the state of the art the textbook skips. So we've seen what AI does in one honest company. But if the old textbook models are creaking and the simple vendor promises are hype, what does the actual state of the art look like? Who built it and who is winning with it today? This is the other side of the textbook. Start with the foundations, because you should always know who built the thing you're leaning on. SCORE, written in 1996 by 2 consultancies, The Bullwhip Effect, Jay Forrester at MIT in 1961, The Safety Stock Maths Every Warehouse Runs On, Ford Harris, 1913. These are the bedrock, and every one of them is showing its age. SCORE was built for a neat, linear chain, so its own owners quietly rebuilt it into a 7-process web. The bullwhip maths still holds, but AI only smooths it. And clumsy auto-reorder bots can make it worse. And Harris's tidy bell curve maths breaks on precisely the fat-tailed shocks the 2020s keep throwing at us. Now, the objection a sharp student always raises, don't the giants already have this solved? And it's a fair hit. UPS, Amazon, Walmart, they haven't run on spreadsheets for 20 years. They run serious operations research, hard mathematical optimization. UPS's Orion Route Optimizer alone saves an estimated $300 to $400 million and 10 million gallons of fuel every year. So if the maths already works this well, what does AI actually add? It earns its place at exactly 4 walls where the classic maths hits its limit. 1, unstructured reality. A solver can't read a weather map or a headline about a port strike. AI turns that mess into numbers. 2, Nonlinear demand. Instead of just projecting, the past forward, AI senses live signals and can even forecast a brand new product with no history. 3. Combinatorial explosion. On a huge network, exact optimization can take hours. So AI learns clever shortcuts that get you a near-perfect answer in seconds. And 4, cause versus correlation. Raincoat sales jumped, but was it the rain or the 3% promo? Causal AI knows the difference before you overorder. So, here's the punchline, and it's the opposite of the hype. AI doesn't replace the maths. It feeds it. Modern systems run 2 tiers. The AI layer senses the world and turns the noise into clean numbers. And then the old, trusted optimizer does what it was always brilliant at and computes the plan. Traditional algorithms do the maths. AI understands the context. The researchers even have a name for it. Predict, then optimize. So what's in the modern toolkit past the basic forecasting? 6 things worth knowing by name. Digital twins, a living simulation of your whole network. Agentic AI, assistants that suggest and take the next best action. Deep reinforcement learning, agents that learn the best ordering policy. Causal AI, cause versus correlation, again. Graph neural networks, treating the chain as a web to see a shock coming 3 tiers away. And foundation models for forecasting, pre-trained the way a large language model is. Some of these are real and is shipping. Some are still mostly a promise, and it matters which is which. So let's be concrete about what's genuinely shipping today. Amazon's Scott team built the first large-scale deep reinforcement learning inventory system, and it cut inventory by around 12% across 10,000 products with no lost sales. Multi-echelon optimization has been quietly running inside the big planning tools for years. And Palantir's knowledge graph, laid over Tyson Foods' creaky old systems, lifted truck utilization from 46 to 87%. About $200 million. Real. Deployed. Unglamorous. And now, the other side of that, what's still mostly a promise. Agentic AI sits at the very start of Gartner's hype curve. The launches are real, but the success stories all come from the vendors. Those fancy foundation forecasting models beat the classics on benchmarks and have almost no real-world supply chain track record yet. And the genuinely exciting stuff, graph networks predicting multi-tier shocks and federated learning to finally break the cross-company data wall, is still on the workbench. Real direction, not yet real deployment. So who's actually winning? A quick field guide, Kinaxis, top of the analyst rankings, Blue Yonder, the old guard, and Panasonic's $7 billion bet. O9, a slick digital brain, though the analysts cooled on it in 2024. Amazon's Escott, the deep learning pioneer. Palantir and the war room laid over your legacy systems. Symbotic, the runaway leader in warehouse robots. NVIDIA, quietly selling the picks and shovels for all of it. And Project 44, knowing where every ship actually is. Don't memorize the logos, notice the shape. And if you want the whole thing on one diagram, here's how it fits together. You ingest everything, sensors, ERP systems, documents, even the news. You unify it into a single knowledge graph. So the machine reasons over meaning, not spreadsheets. You decide, with all those engines, demand sensing, deep learning, the OR solvers, and you act, automatically raising the order, rerouting the truck, with a human watching the exceptions. Predict, optimize, act. Round and round. So carry 3 things out of the frontier. The classics still frame the problem, but each one strains under modern reality. AI doesn't replace operations research, it feeds it. and always separate what's genuinely real. Amazon's deep learning, the knowledge graphs, from what's still the frontier, agentic AI, graph networks, foundation models. Now, what do the serious people say about all this, and where does it still fall over? We've heard from the vendors and from one careful study. Let's hear from the grown-ups in the room, the people who study this for a living. Yossi Sheffi runs the Center for Transportation and Logistics at MIT, about as senior as this field gets. And his line on AI is worth memorizing. Technology, he says, is an augmenting force for many of the uniquely human qualities, not a replacement force. That's the serious consensus in one sentence. AI in operations is real and it's incremental. It changes the job. It doesn't delete the people. But before we get carried away, ain't a cold shower. And this is maybe the most important slide in the whole module. Because most of this fails first, Gartner reckons at least 30% of generative AI projects get abandoned after the pilot. S&P found that in 2025, 42% of companies walked away from most of their AI initiatives, up from 17 the year before. And an MIT study found 95% of enterprise Gen AI pilots delivered no measurable return at all. And the number one reason, it's almost never the model. It's the data underneath, messy, siloed, not ready. 2/3 of leaders say so. And notice, and even the analysts, the people paid to be excited about this, are hedging. Generative AI has slid into what Gartner literally calls the trough of disillusionment, the hangover after the 2024 hype. Agentic AI, the newest wave, is right at the start of the curve, genuinely promising, barely proven, and even autonomous planning only just crested the hype in 2025, and only for the routine, boring decisions, with a human still on the exceptions. The technology is real. The timeline is slower than the brochure. Which brings us back to enable, the sixth S-core process, because that's where the rules live. 3 principles worth holding: auditability, a human in the loop, and proper data governance. As for the law, the EU AI Act is now in force, phasing in through 2027, and it's risk-based. Most supply chain AI sits in the low-risk tier. The heavy obligations only bite when AI is running critical infrastructure. The specifics will date. The principle won't. You must be able to explain a decision, and a human must be able to overrule it. 2 honest cautions to close the chapter. The real risk with generative AI isn't a killer robot. It's a confident wrong answer, delivered with total certainty inside a decision that matters. Trust it like an eager intern whose work you check, not like an oracle. And the regulation debate genuinely cuts both ways. Overregulate and you smother real gains. Underregulate, and you ship decisions no one can account for. Reasonable, serious people disagree about where the line goes. So, remember that most AI projects stall first, and the blocker is data, not the model. Remember, Sheffi, AI augments judgment. It doesn't replace it, so keep a human on the exceptions. And know where supply chain AI sits under the EU AI Act. Mostly low risk. That's the honest state of it. Now, zoom all the way out. Remember the stuck ship from the very start? That wasn't a fluke. So let's zoom out from Sara's warehouse all the way to the map. For 50 years, the goal of a supply chain was one word: efficiency. Lean, just in time, the cheapest possible everything. And then 2020 happened. Now firms are trading a little of that efficiency back for resilience. Near-shoring, friend-shoring, a bit more buffer stock. It costs more on an ordinary day. On a bad day, it's the thing that saves you. Because here are the shocks no algorithm can optimize away. A single ship, the Ever Given, wedged across the Suez Canal in March 2021 and held up a chunk of world trade for the better part of a week. COVID in 2020 and 21, demand whiplash and shut ports. The chip shortage of 2021, which idled car factories across the planet. AI can see these coming a little sooner and react a little faster. It cannot make them not been. So where's it all heading? Towards what people call the autonomous supply chain. The DCM idea from the reading, chains that replan themselves, it's a real direction. It's also, today, mostly still aspirational. And here's the limit worth ending on. AI is the sensing layer. It is not a substitute for Slack, for backup suppliers, for a plan B. The most resilient thing in any supply chain is still, quietly, a margin of safety. So, contrast efficiency and resilience, and why 2220 shifted the balance. Say what AI can do about a geopolitical shock, sense it, replan faster, and what it can't, prevent it, and name the honest limit. AI complements buffers, it doesn't replace them. That's the map. Let's bring it home. Back to Sara. Same inbox, same stuck ship somewhere near Singapore. Nothing about her morning has actually gotten easier, but you can now see the machine she sits inside. And you know what those quiet little tools really do, and really don't. So, our 4 questions answered. What is the machine? Plan, source, make, deliver, return. And it turns small wobbles into big swings. What does AI actually do? Narrow tools, forecasting, inventory, maintenance, routing, negotiation, visibility. What did the evidence show? AI lands on the factory floor, and cost and lead time are the real measured wins. And where do the experts disagree? On how far to trust it, how hard to regulate it, and how much to automate at all. That's the honest picture. Real, incremental, evidenced where it's actually evidenced, and worth a raised eyebrow wherever the vendors get loud. If you want the 8-minute version of all this, go watch the short, and then come and argue with me in the discussion. That's where the learning actually happens.